Good afternoon and welcome to the Embedded Executive Podcast. My name is Rich Nass. I am with Embedded Computing Design. This week's guest is Steve Tadeusian, who is the Senior Vice President and General Manager for IoT, Consumer, and Industrial MCUs for Infineon Technologies. Well, I'm afraid, Steve, we're out of time because that title took so long. Just kidding. How you doing?
I'm great. Thanks. How are you, Rich?
I'm very good as well. Thank you very much. So we met very recently in Nuremberg at Embedded World, and we started to have a discussion. And if you remember, although I'm sure as we both had 1,000 meetings that week, I said, hang on, hold that thought. And this is a great topic for a podcast. So here we are doing a podcast. And as a reminder to you, the topic is artificial intelligence versus, what was the term? Smart computing and intelligent computing, something like that. And where I was coming from this, and I'll take the full blame for this, it seems like we've had these levels of computing that people have been putting on their consumer products. And we talked about in terms of white goods, where they were saying that they had a smart washing machine, a smart dishwasher, a smart refrigerator, and without making any changes to those devices, all of a sudden now they're AI enabled washing machines and dishwashers and refrigerators, but they haven't really changed anything. Is this a marketing ploy? Was it AI all along and they didn't think people would understand it, so they didn't call it that before? Or is it something different? What am I missing?
I think, I'll give my opinion on this, or my perspective here is that there was actually, when you talk about smart devices, there was actually some confusion here. Maybe the word smart really meant connected. It didn't really have, and that was the primary change. When something became quote unquote smart, it meant now it had internet connectivity capability. So you saw that with that wave of smart devices. And I would put smart speakers into this as well. And maybe we'll come back to that a little bit in terms of what's really happening at the edge in terms of AI now versus 5 years ago or 10 years ago. Now we're starting to see AI being added to a lot of these products, or at least from a marketing perspective. And I think it's early. I think some of these things we are seeing, I'll call it like quote unquote real AI capability built into there that is improving the product in one way or another. And then also in some extent, maybe there is AI, but it's just doing something the product already did, just in a different way from a coding perspective. And then maybe there is a little bit of marketing buzz around saying your product is AI enabled as well.
So where are we in the timeline? AI is really new, and you're the right guy to ask this because you're right in the middle of this. Are there end products that are out there now that are using? It's probably not fair to ask if it's with Infineon MCUs, but I can ask that. Are there end products out there that are actually doing AI, or are we still a couple of years away from that?
There are end products out there using on-device, or what we would say is edge AI today in the market, and some of those are doing that on MCU class products. I would say the ones that come to my mind, they're pretty, I'll call it like internal functions that they're monitoring, not necessarily user visible functions. So AI might be controlling power or temperature in a system, or perhaps improving some system level efficiency, or enabling a sensor to be removed from a system because it's using other inputs in an AI model to detect something is happening in the system. So nothing that you would, in that regard, like an end consumer wouldn't necessarily say, wow, look at the benefits I'm getting from having AI or an ML model running in this device. That being said, there are other products, and I mentioned smart speakers earlier, which if you go back, I'll say to the first few generations of smart speakers, those you could call those AI devices, but that wasn't really running on the edge. It wasn't running in those devices other than perhaps the keyword. But even that in some cases wasn't really running on the device. But now you start to see these smart speakers really start to evolve. And more and more of the language processing is happening on the device itself and not needing to go to the cloud. And I think that's one area where we really are seeing traction and movement is on audio use cases in general. And I put, language recognition, translation, dictation, um, noise detection, or system monitoring through microphones as a sensor. So this whole audio class is some area is one specific area where I think we're seeing, some initial traction for this technology to be running locally at the edge. Because a lot of those use cases, and if you remember those smart speakers that had to go to the cloud to turn your lights on or off, like they were non-deterministic and the latency was maybe 1 second, maybe 5 seconds, you didn't know, right? So there's a lot of things, not just in our daily lives, but especially in manufacturing environments where determinism and real-time control matters, and you can get that if those models are processing on the edge instead of relying on some kind of cloud connectivity.
You've mentioned models a bunch of times, and we know that the models continue to get better. Is it fair to say that in a couple of years' time, when we have a lot more data, these products will work better than they do today?
Well, for sure. And I think we're seeing that happen pretty rapidly already. At least the model's getting better, not necessarily the products themselves getting better. But I think what we will see, and I would say what we are seeing, is that developers are thinking forward in terms of the hardware that they're using, what those models might evolve to over the next 2, 3, 5 years. So once those products are deployed in the field, like maybe a year from now, maybe it's even 6 months from now, or maybe it's 3 years from now, as those models improve, they're able to update the firmware on those devices where those models reside, and the product itself, the end user then sees an uplift in performance or capability of that product.
Are we done with the term smart? Because that's a checkbox that's so low on the priority scale now. I mean, it's just something that just has to be there.
I don't know. I don't know if we're done with the term, but I would agree with you. Like this basic capability and connectivity, I think is pretty commonplace now and expected in most devices.
But that assumes that we're using the definition of smart that you gave it, that smart is really analogous to connected.
Yeah.
And I'm not sure how fair that is, to be honest with you, because I think people think of smart as other than just connected.
Yeah, they do, because the term is misleading. Maybe what we will see is smart start to transform to intelligent, so an intelligent device as opposed to a smart device. And that intelligence being, what the AI capabilities can deliver to the user or to the use case.
And in the world that I tend to live in the embedded space, there's an intermediary step there as well, which is machine learning. We spend a lot of time talking about machine learning, where the device learns from its own actions, from the actions of the environment, and is able to make decisions, which isn't really AI, but it can certainly be. You could probably make the argument that it could fall under that umbrella.
Sure. Yeah.
Okay. So wrapping up here, what do you see as the short term and the long term with artificial intelligence in the types of products that we're talking about? If I'm a developer, where do I go? That's probably the right question to ask you. What's the decision that has to be made by the developer at the initial stages?
That's a great question, and I would say there's probably many decisions that they would need to make, and I think most developers, or many developers today, are actually wrestling with the first question, which is, how does this make my product better? And I think in the first generation, maybe even the second generation of a product, using ML in the product may not actually make the product better from an end user perspective, but it will future-proof it for the way the industry is moving. And I think a lot of developers are looking at this now, not just in terms of their own workflow, but how that will impact their products to come. So I would say, first of all, the decision is not if, but when. So do we enable this capability in terms of how we deliver the functionality of our device? Do we enable this on this generation or the next generation? So the when, not if, because the if is yes, they're going to. And if I go back to that audio example, this is an area where I think ML capabilities are really starting to shine in this area. And yet, if you're a developer and you have 5 generations of products over the last 10 years, let's say, that do audio based on traditional DSP approaches, making that change in this next generation may not be as a one-off decision, an easy one to make. But when you look at the capabilities and the development time that and the flexibility that such an ML solution can bring to you in the future, that's when you need to think about, okay, do I do this now or do I wait another generation? But I know I'm going to need to do it at some point. The other thing that I would say is that I think there's 2 things that are happening, and both represent real opportunity for Edge ML. One is, like I talked about, that audio use case for a smart speaker, where there's more and more of what was happening on the cloud now happening locally on the device. The other thing, and where I see a lot more traction today actually, is on devices that, yeah, they may be cloud connected historically, but they weren't using they weren't running models in the cloud. Actually, they didn't have any ML capability at all. And now those developers can make those products better and add new capability to them in a really cost-effective way by putting a model to run on the device itself.
That was very well said. I have nothing to add to that. You put it perfectly. Thank you very much.
All right.
I appreciate taking the time, Steve.
Yep. Great as always.
That was Steve Tadeusian. He is the Senior Vice President and General Manager of IoT Consumer and Industrial MCUs with Infineon Technologies, and I'm Rich Nass with Embedded Computing Design.